Hello everyone, welcome to the course of Data Structures and Algorithms with Hands-on Projects. This course is basically designed by me, that is Sonal Palve, and my teaching assistant Sakshi Kapil. We both will try to give our best to make you easily understand what data structures and algorithm is. Also, we are providing some hands-on projects for you at last of the course. So let's begin. Firstly, we will discuss some content about my course, data structure. In this module, we will see what is data structure, need of data structure, and applications of data structure. Then we'll go to see algorithms and algorithms, and at last, we will see the types of data structures, which will include linked list, queue, stack, trees, graph, etc. Then further, we will implement data structures using C programming. And at last, we will also deal with some hands-on projects on data structures. This will basically give you idea of applications of data structures. So let's begin with our first question, that is, what is data structure? Data structures can be defined as the collection of data objects which provides a way of storing and managing data in the computer so that it can be used. It's a typical definition. Let me explain it in easy terms. Data structure means data plus operations. For example, contact list in your mobile. Have you ever gone through your contact list in mobile? In contact list, the contacts have been sorted in alphabetical order. Like someone's name is Aaron, so his name will be stored at first place, that is in A block. And likewise, if someone's name is Marina, so her name will be placed in M block. So whatever these contacts are, it could be called as data. And operations like inserting someone new contact. You can say that adding someone's new contact and deleting someone's contact, then changing, it means renaming the contact name. These operations could be performed on whatever data you have, that is whatever contacts you have. Likewise, data structures also work. Data structures do some operations on the data present over there. And this data could be stored in different forms. There are several types of data structures to store this data, such as linked list, tree, queue, stack, graph, etc. We will see them one by one in detail in further courses. Okay, let's move. Why to study data structure? The first question arises in our mind. Suppose if you want to find your roll number in 20,000 pages of PDF document, what would you do? You will either go randomly or let's do some smart work. Follow this step. Firstly, we will go to the page number 10,000. We will search out your roll number. If your roll number is not present there, but you know that all other roll number is less than yours, then what you will do? You will go in increasing order. That is, you will go to the page number 15,000. But still, if your roll number is not found, but you know that other roll number is greater than yours, then you will go to the page number 12,500. And likewise, this procedure is done till you get your roll number, right? And believe me, within 30 to 40 seconds, you will get your roll number very easily and quickly. So, congratulations, you have been used binary search unintentionally. Yeah, binary search is one of the type of data structures. Data structures and algorithms help in understanding the nature of the problem at a deeper level and thereby a better understanding of the world. Moving to the next, why do interviewers ask questions mainly based on data structures and algorithms? Engineers working in Google, Microsoft, Facebook, like such companies are different than others and paid higher as compared to other companies. But why? Is this question arise in your mind? So let me tell you, in this company, coding is just the implementation and roughly takes 20 to 30% of the time allotted to a project. It saves the companies thousands of dollars. Yeah, most of the time goes into designing things with the best and optimum algorithm to save on the company's resources, such as servers, competition, power, etc. Candidates who can optimize their software as per user demand. This is very main reason because these companies are searching to the candidates who can think out of the box to design algorithm that can save the companies thousands of dollars. And this is the main reason why interviewers in these companies are focused on algorithms. Hope you got my point. What are the advantages of data structures? Efficient memory use, reusability, and abstraction. Yeah, abstracting data is really more easier with this data structure. Applications of data structure. This is very interesting part. So, you probably use social media like Facebook, LinkedIn, Instagram, and so on. Social media is a great example of a graph being used. I know at this instant you don't know about graph, but let's take an example of it. Yeah. A graph is a network of interconnected items, and each item is known as a node, and the connection between them is known as edge. Focus on these two words, nodes, edge. Here I will give a quick example. Let's take an example of Facebook. Suppose one of the user whose name is Rohan and someone's name like Lily. She is another user. They both get connected on Facebook, right? They became Facebook friends. So in here, there exists an edge connection between them, right? Whatever the Facebook connection they have, that could be called as edge. Means there exists an edge between Rohan and Lily. Likewise, the more we are connected with people, the nodes and edges of the graphs keep on increasing. This is one node, this Rohan is one node, and this Lily is another node. So these nodes and these edges which exist between them keeps on increasing as we connect with more people. Or you can call them as mutuals, right? Another example is Google Map. Similarly, Google Map is another example where graphs are used. Like, in the case of the Google Map, every location is considered as nodes and roads between locations are considered as edges, right? And when one has to move from one location to another, the Google Map uses various graph-based algorithms to find the shortest path. We will discuss this later. And likewise, there are many more applications of data structures. Algorithms. What are algorithms actually? Algorithm is a step-by-step procedure to solve logical and mathematical problems. Step-by-step procedure means, let's take an example that steps you follow to make cold coffee, right? You make cold coffee by using sugar, sweetener, coffee powder, and many more things like ice cubes. Here you follow some steps to make cold coffee. Like you first will take glass, then you will take milk, pouring coffee powder in it, then pouring sugar, adding some sweeteners, mixing it well, and at last adding some ice cubes. Right? So what you do, you follow some steps, and this step-by-step procedure is called as algorithm. Right? Moving further with analysis of algorithm. So what is analysis of algorithm is actually? There are several methods or algorithms to implement for performing a specific task. So to decide among them which one must be obtained, analysis of algorithm is done. And it mainly consists of two factors, that is time complexity and space complexity. For example, just we took the example of cold coffee, right? Mm, For making cold coffee, there were two algorithms available for you. Either you will make coffee at home, or either you will go to cafe and have the ready-made coffee. So how will you prefer that which algorithm must be opted? Either you make coffee at home or have coffee by directly going to cafe. So here the time complexity concept comes. You will check which algorithm will take less time, right? That is, making coffee is really time consuming, as you will go to the market, you'll purchase whatever requirements you need to make coffee, and then you will come to home and make coffee. But rather than going to cafe directly and having coffee takes less time, right? This is how the analysis of algorithm work. And the next term comes the space complexity. We will discuss these both factors in upcoming sessions, so don't worry. The next one is pseudocodes. Pseudocodes is an artificial and informal language that helps programmer develop algorithm. Means you can say pseudocode as like outline or blueprint which helps you to develop algorithms which you are going to actually implement to make some program, right? It has no syntax like any of the programming language and thus can't be compiled or interpreted by the computer. For example, the way the if else for while loop are indented in a program, indent the statement likewise. This is one example I have just shown. Like you'll just make some outline that I'll take this condition if and if this condition is true, this statement will be printed, and you will define some cases there, right? Means you will print that I am case one. Then you will take some second condition, then you will go for printing it again. So likewise, these steps you have just defined, or you can say it is like a rough work. You will come to know that yeah, I have to do some algorithms like this. I have to perform algorithm like this. I have to put some condition if statement. So hey guys, thank you. See you in the next class.